Here we're going to learn about systems of linear inequalities. So far we know about a linear equation, which looks like this. Y equals an expression where we can graph the x and y coordinates from that line. That's what a linear equation is. A system of linear equations is just more than one of those. We've seen inequalities with only one variable. So that looks like this. 2x is greater than negative 7. Now we're going to learn about linear inequalities, which is going to have an inequality symbol, greater than, less than, or equal to, greater than or equal to. But now we're going to have a linear inequality, which means it's going to have an x and a y that we can then graph on a coordinate plane. So instead of just using a number line for an inequality, we're going to be talking about an inequality represented on a coordinate plane, and more than that, we're going to be talking about systems of linear inequalities, so two linear inequalities on a graph at the same time. Before we get into that, let's just review what a linear equation looks like and what an inequality looks like. So we're going to use this linear equation, y equals 1 minus 1/3 x, to answer those two questions. The first one is, what is the value of y when x is negative 3? So we're really just going to plug in negative 3 for the x value and solve for the y value. The first one says, what is the value of y when x is negative 3? So we're just going to take that negative 3, plug it in for x, and figure out what y is. So y equals 1 minus 1/3 times negative 3. We're going to follow the order of operations, so we're going to multiply first, negative 1/3 times negative 3. That's just a positive 1, so we write plus 1. So y equals 2. That means we have the ordered pair, negative 3, 2 on this line. So negative 3, 2 on the graph is actually hit by that line. Letter B is asking us to test a point. Is 12, 4 a point on that line? So we're going to do the exact same thing, except now we're given the y value. We're going to plug in 4 for y and 12 for x, and we're going to figure out if this is a true equation, if that's actually a point on this line. So 4 equals 1/3 times 12 is 4. 1 minus 4 equals negative 3, and 4 does not equal negative 3, so no, that is not a point on that line. We did not get a true statement when we plugged it in for the x and the y. 2a is similar. We're going to take negative 3 and see if it's a solution to this inequality. We're going to just test that. 2 times the x value that they give us, the solution that they're giving us, is negative 3. And we're just going to see if that's actually a true statement. Negative 6 is greater than negative 7. Well, that's true. Think about it on a number line. Negative 6 is a smaller negative, so it's actually a bigger number. It is greater than negative 7. So yes, it is a solution. When I want to graph all of the solutions, that's talking about graphing this inequality. I'm going to solve it first. I'm going to get x by itself first. So 2x is greater than negative 7. I'm going to divide by 2. That gives me that x is greater than negative 3.5. So I'm looking at all of the x values greater than negative 3.5. I'm going to put an open circle above the x and put a line going to the right. It's all the numbers that are bigger than negative 3.5, so like negative 3, 0, 1, 2, all the numbers bigger than negative 3.5. This symbol means that they are not the same. And because we don't have the line underneath there, we don't fill in this circle. There's a really similar idea to that when we start graphing them in a two-dimensional coordinate plane, which is exactly what we're going to do right now. Linear inequalities means it's a line that's formed by an inequality. It's really similar to linear equations. They look very similar. We can actually pretend that this inequality is this equation when we graph it. That's what we're actually going to graph. We're going to graph that equation. We're going to pretend there's an equal sign, and then basically just graph that line. There's a couple key differences though. So I'm going to start off just by graphing that line. We have a y-intercept of 3, and a slope of negative 2/3. A y-intercept of 3. I'm starting out at 3 on the y-axis and just walking out my slope, which is negative 2 over 3. That's my rise over run. So I'm going down 2, down 1, 2 spots, and then over 1, 2, 3 spots. That's my next point. And I can't really go forwards on that anymore. I can't continue going to the right, so I'm actually going to backtrack and go to the left. I'm going to go back 3 spots, 1, 2, 3, and then up 2 spots. So that's 3 points on this line. And I'm not going to connect those dots yet. Before I do that, I want to decide whether this is a solid line or whether it's a dotted line. If it says less than or equal to, or greater than or equal to, then it's a solid line just like before. We connect the dots and make a solid line that runs straight through those. If it's just less than, like this one, or if it was just greater than, then it's going to be a dotted line. So it's going to be a dashed line that passes through those points. It's still on that line, but instead of being a solid whole line, it's a dotted line. And the reason that is, let's just pick one of these points. Let's take this point, 3, 1, and see if it makes this inequality true. So I'm going to plug in 3 as my x value, 1 is my y value. And I just want to test to see if this is actually a true statement. So I'm going to follow order of operations on the right side. Negative 2/3 times 3 is negative 2. Plus 3 is 1. So 1 is less than 1. That's what that ends up simplifying to. That's not a true statement. 1 is not less than 1. That is not true. So we don't actually want to make a solid line there because these actually are not solutions to that inequality. They just happen to be the border of the inequality because it's represented by that equation. We don't complete the line because points on the line actually are not solutions to that. They make this inequality not true. Now, let me clear this off so I can redraw that. Alright, so that's one aspect of it. If it's dotted or solid. This one happens to be dotted because it's a less than symbol, so it's a dotted line. And the only other difference is that we're going to shade one side of that line. We're either going to shade all the points below it, or we're going to shade all the points above that line. It's saying that it's saying that y is less than that expression. We're talking about all the y values that are smaller than this line, all the y values that are less than or below that line. You're shading everything below that line because it's saying y is strictly less than that expression. And these are the solutions that I'm looking for. Everything that's shaded underneath that line is a solution to that inequality. And I'm going to test this in this first one. It's asking, is 0, 0 a solution? So I'm going to plug that in. 0 is my y value, and actually it's my x value. So I'm going to plug that in. Negative 2/3 times 0 is 0. Plus 3 is going to be 3. So you get the statement 0 is less than 3. That's true. That's a solution to this inequality. And another way that we can see this is on the graph. 0, 0 is hit by the shading. It's covered in that shading. So yes, it is a solution. 3, 3 is not a solution because 3, 3 is outside of that shading. Nope. 3, 3 is not a solution because it's not covered by that shading. I'm shading everything below that line. And then I'm asking you here just to make up a ordered pair that is a solution. I'm going to make up any random one. Let's say negative 5, negative 5. That's definitely in the shaded area. Negative 5, negative 5. That's what a solution means when we're talking about these linear inequalities. Anything in the shaded area. All right, the next one says y is greater than or equal to. I'm not sure what just happened. Greater than or equal to. And of course, that's what should. y is greater than or equal to 3x minus 4. I'm going to just change that into an equation. And that's the borderline that I'm going to graph. I'm going to graph y equals 3x minus 4. So I have a y-intercept of negative 4 and a slope of 3. That's a rise and run of 3 over 1. So from that spot, that original spot, I'm going up 3 and over 1, up 3 over 1, up 3 over 1. This one, oh, I'm sorry, I forgot to put my extra star here. Sorry. This was a dotted one, and I shaded below the line. This is going to be a solid line because it's greater than or equal to. So it's going to be a solid line. So I'm just going to connect those dots just as normal. I kind of missed, but that's okay. It's just a solid line that passes through those 4 points. And it's saying it's greater than or equal to. So it's all the numbers that are bigger than it, so I'm shading above the line. I'm shading on the top of that line. So all the solutions are above that line, and actually they're included on that line. These points are solutions because it's greater than or equal to, not just greater than. Now I'm going to see if these are solutions. So 0, 0 is in the shaded area. Yep, that's a solution. 3, negative 3, that is not a solution. Not in the shaded area. Another ordered pair that is not a solution. So I'm going to just go with 4, 0 there. That is not a solution. So it's basically just graphing a linear equation and then deciding on 2 things. Is it a solid line or a dotted line? And then am I shading above or below the line? Those are the only differences between an inequality and a linear equation. All right, on the next page, these two look a little bit different just because they're not in slope-intercept form. So before we do anything, we just have to figure out how to graph these. The first one, number 3, we don't actually have to change that into slope-intercept form. Point-slope form, which is what this is pretty easy to graph as it is. It's giving us a point. It's usually written like this, where the x1 and y1 are just coordinates for a point. So the point 1, 2 is a point on that line. Then the slope is the m. That's just sitting in front of the parentheses, so our slope is 2. So we have a point and the slope. Let's just graph those. 1, 2 is there. With a slope of 2, that's really a rise of 2 and a run of 1. I'm going up 2 and over 1. I can't keep going forward, so I'm going to go backwards. I'm going to go down 2 and back 1 spot. I'm going to keep doing that. Down 2, back 1, down 2, back 1. So I have my line. And I want to now decide, is that a shaded, if that's a dotted line or a solid line. That's my first thing to decide. I see that it's just a greater than symbol. So that's going to be a dotted line. I'm going to make those dashes at that spot. And it's saying it's greater than this side. The y values are greater than the values on the right side, greater than the x values, really. Or at least the x values represented with that expression. So we're shading greater than, we're shading above this line, we're shading on top of it. So you graph it just like an equation, and then you decide on those 2 things. Is it dotted or solid? And then are we shading above or below? So 0, 0 is actually a point right there. It's on my dotted line. That is not a solution. If it's on a dotted line, that means it's not a solution. If it's on a solid line, then it is a solution. It actually makes that inequality true. But in this, we would get something like negative 2 is greater than negative 2. If we plugged in 0, 0, then that's not true. So that's not a solution. 3, 3, we can clearly see 3, 3. That is not in the shaded area either, so no. And then we're looking for another ordered pair that is not a solution. Something that's not a solution, let's just go with 1, 0. That's outside of the shaded area. All right, number 4, we have to change that from standard form into slope-intercept form. So we want to get it to look like slope-intercept form, just so that we're allowed to graph it easily, or able to graph it easily. So I want to get y completely by itself. I'm going to solve the inequality as it is. Don't change that into an equal sign. You have to actually solve the inequality, just like that, for y. So I'm going to try to get y by itself. My first step is subtracting 4x on both sides. That gives me 2y is less than negative 4x minus 2. So I'm almost done. I almost have y completely by itself. I still have to get rid of that 2, so I'm going to divide by 2. When you divide by 2, you divide it into all the terms on the right side. Negative 4 divided by 2, that's negative 2x. And negative 2 divided by 2, that's negative 1. This just simplifies to just y. You have to be really careful about this step. If you divide it by a negative number, that inequality sign has to flip. Remember, anytime you multiply or divide by a negative, this sign will flip directions. We divide it by a positive, so we don't flip it. So now I'm going to try to graph this. I have a y-intercept of negative 1 and a slope of negative 2. So I'm going down 2 and over 1, down 2 and over 1. So that's my line. Now I have to decide on my 2 things. Is it dotted or solid? It's going to be a dotted line because it's not less than or equal to, it's just less than. So that is a dotted line. It's not really straight, but that's okay. You get the idea. And it's talking about y values that are less than that expression. So we're going to shade below. We're going to shade numbers that are less than that. We're going to shade below the line. So is 0, 0 a solution? Nope. That is outside of the shaded area. Is 3, negative 3 a solution? Nope. That's also outside of the shaded area. And then we want to write one more ordered pair that is a solution. So let's go with 0, negative 3. That's in this shaded region. All right, these are just some special cases that I wanted to go over. They work exactly like before, except there's little wrinkles that you have to just be careful about. So the first one, x is less than or equal to 4. Let's pretend that's just x equals 4. That has an undefined slope, and x is always 4. X is 4, 0 there, x is 4, 1, x is 4, 2, x is 4, 3. X is always at 4. That is just a vertical line, straight up and down at 4. And it's a solid line because it's less than or equal to. You make a solid line. The problem is we can't shade up or down on this. We can't shade above or below because it's saying x is less than 4. So it's a vertical line. There is no up and down there. There's either left and right. And we really just want to think about what this means. X values that are less than 4. X values that are less than 4. The x-axis is just giving us our x values. So we're just talking about all of the x values that are smaller than 4. Everything that way. That's where we're shading. We're just shading to the left of that vertical line. All the numbers to the left, all the x values that are less than 4. So 3 ordered pairs that are solutions. Let's go with 0, 0, 0, 1, and 0, 2. All of those work. 0, 1, and 0, 2. All right, the next one is similar. Before we can actually start graphing that, though, we have to get y by itself. We have to solve for y. So my first step is going to be to divide by negative 1. So we get y by itself there. The negatives cancel. We get negative 3 on the other side. And when we divide by a negative number, we have to flip the inequality symbol. So instead of pointing at the 3, now it's going to point at the y. Now it says y is less than negative 3. So we're just going to graph that first. Let's pretend it's y equals negative 3. Y is always negative 3. Let's just find that spot. Y equals negative 3 there. y equals negative 3 here, y equals negative 3 there. It's negative 3 all along that line. So I'm going to draw a horizontal line there. But y is strictly less than negative 3. It's not less than or equal to, so it's going to be a dotted line. So we have a dotted line. And we're talking about numbers that are less than that, so numbers like negative 4, negative 5, everything that is below that line. All right, number 7, we're going to have to rearrange that first. We, again, need to get it to be slope-intercept form, or y equals mx plus b. So we've got to get y completely by itself. Actually, even before I start solving it, I know the y has to end up on the left side. So I'm going to switch this inequality around. I'm going to bring the 6y minus 12 to the left side. I'm going to switch this around. I'm going to put the negative 6x on the other side. And if you flip the two sides, you also have to flip the inequality sign. So instead, it's going to be a less than or equal to symbol now. All I didn't change anything really. All I did was flip that inequality, just so I have my y on my left side. Now I'm going to solve for the y. I'm going to add 12 to both sides. That gives me 6y is less than or equal to negative 6x plus 12. That's a 12 at the end. And then I'm going to divide by 6. I want to get y completely by itself, so I'm going to divide by 6 into both of these. Everything needs to get divided by 6. So that gives me y is less than or equal to, the sign doesn't flip because I divided by positive, negative 1x plus 2. That's supposed to say, this part says 12 divided by 6. That gave me that 2. So I'm going to graph that, a y-intercept of 2, and a slope of negative 1. So down 1 and over 1 each time. We have a solid line because it's less than or equal to. And we're going to shade below the line because it's less than. It's talking about all the numbers that are less than that line. So now let's go back and do the solutions for 6, and we'll do the solutions for 7 also. So 3 order pairs that are not solutions. Let's just use these 3 points, 0, 0, negative 1, 0, and 1, 0. All of those are above that line, so they are not solutions. On number 7, we want things that are solutions, and they have x values of 0. So an x value of 0 and a y value of 0 actually works there. So 0, 0. Let's go with 0, negative 3, and 0, negative 5. All of those 3 points are solutions because they're in this shaded area.